All right. So jumping in halfway here, but yeah. So this is just referring to when I'm saying u of n minus 1, I'm just referring to the term before u of n because I'm trying to find this term. I'm trying to find this term right here, and I'm going to find it based off of the previous term. That's what the recursive function means. I'm just a pattern of numbers that I'm finding based off of the previous number. So that's all that your n is just basically which number am I looking for? And just, it's nice to use n because then we can say it's any number. We could say it's this one. We could say it's, way down the line. We could say it's way before the line. So let's see here. So let's do a couple of examples here. So what we're going to be looking at is going to be this first one, where we know that u of 1 is equal to 5. So this is always going to be your given information. You're always going to start with something like that. It says u of 1 is equal to 5. Sometimes this number here will change. We'll get into that a little bit more. For right now, we're going to skip this part of it because we're not quite there yet, but we will get there. So u of 1 is 5. And now we're searching for u of some term is equal to the term before it plus 4. So let's say that I was going to, I'm trying to find what is u of 2. So I know that u of 1 is equal to 5, and u of 2, what do we think u of 2 is? 9. Sounds right to me. And just using our thing, we're trying to find u of 2. So we're going to use the term before it, this guy, and we're going to add 4 onto that. So this u of n minus 1, in this case, since we're trying to find u of 2, 2 minus 1 is 1. So we're just using the term before it to add to it. Seems pretty simple. What's u of 3? 13. Awesome. And then so on and so forth. U of 4 would be 17, and so on. So same thing. Let's take a look at the second one here. Why don't you guys work on that and find the first 4 terms of u. So find u sub 1, u sub 2, u sub 3, and u sub 4. And then once you do, compare your answers with the person sitting next to you. These 2 rows just pair up right down the rows there. Have u2, I'll have u3 there, and then I'll have u3 there, and then 2 in the back. Then let's go, this will be a little bit weirder. Let's do u3, 2, and then u2, and then u2. And just find the first 4 terms of u and compare them with what you get for the person next to you for this example right here. All right, what do we get for our first 4 terms? U of 1 is equal to 12. U of 2 is equal to 6. 0, negative 6. And yeah, that's right, because all we're doing is we're just taking off 6 from our first term, which is given to us of u of 1 is equal to 12, going on from there. That's kind of how you use these things to figure it out. And like I said, you'll always be given this piece of it here. And then, of course, you would need this one to know what you're doing, and then going from there. So real quick, I'm going to talk about these n's here. So this is just essentially saying your domain. This is saying where can this thing work. So this is saying where n is greater than or equal to 2. Why do you think they chose the number 2 for n? Do you have any ideas on that? Because 12 divided by 2 is 6. Okay. That's not the reason why, but yeah. Okay. Yeah. So this is saying that that's going down the right trail. Yeah. Did you have one back? Mm-hmm. That was just a random sequence that I had made. So no. What you got for me, Mr. W? Ah, there it is. That's that. Trent, did you have something to add on to that? It can't be smaller than 2. Yeah, that's a good way to say this. Because this is our first term, and this is a recursive function, or a recursive sequence. So even though we can guess, -6, so we can guess that u of 0 is probably 18 because it's easy to see. Technically, mathematically, we only know this. We've only started with this. So like a great example of where this applies is, let's say that you're given, the population of some town is 1,500, in 2009, say. Well, and then you're given some function that it's adding 25 people a year. I can guess that probably it's just going to be 25 minus this 1,500, but I don't actually know what the population is for 2008. I don't actually know that. So that's kind of where we're going with some of this stuff, but we're just starting with simple stuff here. But yeah, so long story short is this. The reason why it's 2 is because it has to be 2. It has to be bigger. It has to be 1 bigger than this first term because we have to start with our starting information and go up. So the simple rule of thumb is whatever this starting value is here, whether it's 1, it could be 0, it could be 2009. You could say u of 2009, giving you the first year of the population. This n is just going to be 1 larger than your very first term. So that's what's going to set our domain there. So let's see here. So we're going to give these sequences a name where we're just adding things on or subtracting things down. These are called arithmetic sequences. Arithmetic sequences. Not arithmetic, arithmetic. So, and how we know that this is this, what defines this is the common difference. This would be something that you might see on a test to say, what's the common difference of this? So, like, once again, using our example here of 2, 4, 6, the common difference would just be, what's the difference between from 4 to 2? It would be 2. And so that's what's going to be our common difference, and this is an arithmetic sequence because we're just adding or subtracting 2 depending on the sequence. In this case here, we're adding. So just be adding 2. Eventually move into geometric, and geometric is doing multiplication and division, but for right now, just doing arithmetic. So, so here's what I'm going to do. I'm going to give you a quick example here of this, and then we're going to do this part of the activity here. So we're going to come up with one. So I'm going to come up with 2, 4, 6. We're going to add 8 in there, just to make it a little bit longer. And that is going to be my sequence. Now you guys are going to choose a harder sequence. I'm choosing an easy one for the sake of the example here. So, so this is me coming up with the sequence. And then the next thing that I'm going to do is I'm going to pass it to somebody, which is going to be all you guys, and then I'm going to write down the starting term and what the rule is for the sequence. So what's my starting term here? Exactly. So u sub 1 is equal to 2, and then I'm going to write down my rule. Does anybody want to take a stab at writing the rule for us? Yeah. un minus 1 plus 2. Does everybody else agree? Raise your hand if you agree. Yeah. Yep. This is awesome because this is saying I'm looking for this term and I need the term before it. So like if I'm going to find u of 2, I would just plug in that and go from there. Awesome. So why don't you do this now? We're going to do this activity. Why don't you come up with a sequence and then pass it over or just show it to the person sitting next to you, and then each of you are going to write down the starting term and the rule for the sequence. And of course, we're not going to forget our n is greater than or equal to 2 to tell us our domain. Ready? Go. All right, let's have somebody give us their sequence and their rule. Start right back there, Mr. A. What is your sequence that you came up with? Yes. 4, 8, 12, 16, and I'll stop there. Okay, so then what's the rule that you came up with? Un minus 1 plus 4. And what goes out front of this guy is equal to, sorry, u of n. It's equal to u of n minus 1 plus 4. And then what else do we need in our rule? I finally located the voice. Yep. But what else do we need? Yep, we're always given our starting term. So u of 1 is equal to, in this case, 4. And then since we're calling that u of 1, going to go n is greater than or equal to 2. I could, if I wanted to be difficult, I could call this u of 0 just to be difficult. And then my n would actually be 1 because I'm just going up. In this lesson, we're basically just going to hang out with these u of 1, and then n is greater than or equal to 2. But in theory, I could call that u of 0 if I wanted to. It's just some number. Let's get another person's sequence up here. Yes. Yeah. Talk to me about what you're confused about with this. Mm-hmm. Yep. U of n of 1. So u of n of 1. So yeah, so let's just talk through this here quick. No. This is good. This is. Oh, I can certainly move you too if you need to. Okay, yeah. Why don't you just slide up into one of those other desks there? That's fine with me. So yeah, so this n piece, this is going to be your most common mistake, your most confusing thing. The way to think about this is to think about it in that sequence that we did before, where we did. Let's go back to that. This guy here. Oops, not that guy. What did I do with that? This guy here. So once we get farther down the line here, we're just calling this u of n. So n is just some number, and then we're just looking at the number before that to get the rest of it. I shouldn't have gone all the way back here. Let's go back to where I was. Right there. Okay. So yeah. So Nemo, just to clarify this here again. So basically, what this is here, this is not a huge piece of it. I don't think that this is a super big deal, but it is something. It's technically part of the domain. So basically, what your golden rule is, whatever this value is here for your first given term, because you're always going to be given this. You're always going to be given your first term. The golden rule is whatever your n is, it's greater than or equal to 1 plus whatever that is.
So could n be 1.5?
So n could be 1.5. We're going to be doing whole number stuff. It just gets a little messy with that. But yeah, so or you could say if u of 1.5, just to be extra tough, and then our golden rule, we're just adding 1 onto that. So our n is greater than or equal to 2.5. In theory, you can do this. I don't know if I've ever seen a sequence that has a 0.5 down here, because it just is unnecessarily difficult, because you're generally dealing with it in steps, and you're not too concerned about what's in between those steps, what's in between 1 and 2, or 2 and 3. So you can do that. I haven't even seen it. So yeah, just usually you're going to be going in whole numbers. Yes?
So that kind of comes into like each individual term. So if it's like u of 3, get n is greater than or equal to 4.
Yes, if u of 3 is your first given term. So let's say here, so u of 1 is equal to 4, u of 2 is equal to 8, u of 3 is equal to 12. Well, here n would not be 4, because we're just doing it based off our first given term. Does that kind of make sense?
How would you get like your first?
it's since this is just an arbitrary number that's being chosen. So, maybe there's some situation where it's like, hey, I started tracking my data after my third cast of basically how many fish I'm getting per cast, or some sort of a thing like that. So for some reason, I'd like to start at 3 to remember that I didn't start at the beginning. I started at the third one. So this is just this number here, this first given value, and this one here. That's just an arbitrary chosen number that is chosen to fit your data best. And in our case, we like 1 because 1 is easy. That's what we always start with for counting. So that's the only reason why we're choosing 1 versus any other number. All right? Did I see a hand back there? Nope. Okay. Sounds good. All right. So let's move forward here. Let's do example 1 technically. So we're going to do this. We're going to find out what is the common difference. We're going to write that rule or that recursive formula that generates this sequence, and then we're going to figure out what the 11th term is. This is a little bit of a sneaky one, but yeah, why don't you guys start on that? Compare your answers with the person next to you. All right, why doesn't somebody help me out with this? Answering these questions. Let's go in the back to Mr. T. So what's the common difference? -7, and that sounds right to me there, because we are dropping it by 7 each time. Yep. What's the recursive formula that generates this function? Yes. Yes. U of 1 is equal to 20. Yep. UN minus 1 minus 7. Perfect. And then, did you forget anything? Yes. So that's always going to be part of it. You're always going to need all 3 of those pieces. So
is it always going to be n is greater than or equal to 2?
yeah, so this is the concept that trips up most people. No, and this is fine. I mean, like, I want you guys to ask every time that you have a question because that repetition is good. This is the most complicated thing that always trips people up. It's not always going to be that. For all of our examples today, it is, but it doesn't have to be. If I'm given the first term, if my first term was given to me as, U of 3, for some reason they decided 3, maybe just to be annoying, is equal to 20. Well, this is my first term, so I don't know what my second term is because this is my first given term here. So then there, my golden rule, I'm just taking this and I'm adding 1, so then n would be greater than or equal to 4 there. And most of the time, if this is a different number, there's a reason. It's a year. It's a specific number of things that's going into it. There's usually a reason. Otherwise, you're usually going to start with 1. So 1 is your most common. It doesn't have to be. So yeah, don't ever be afraid to re-ask a question because repetition is very good. That's how marketing works. So and then last one here. What is the 11th term? Who actually got us the 11th term?
The actual 11th term?
Yeah. What'd you? Okay. Yes.
No, actually, I think it.
All right.
My calculation is -50.
-50, huh? You got -57. So -50 or -57. So so to actually do this technically, we'd have to go and write out each of our terms and find that out. Of course, you can do the math on it and just say that it's -7 times by the number of terms. Technically, I believe that this would be -50 because the 11th term, you've already been given the first one, so you're multiplying it by 10 to do that. Or yeah, so that's actually the opposite of what I just said. You would technically be multiplying by 10 because you've been given your first term, and then you're taking that term and you're subtracting it 10 times to get the 11th term. But I'm not super concerned about this. We're going to be putting these into our calculator. I'm not super concerned about if you can get that math right. We'll put them in, and that'll be great. Yes? So, like, I hardly even want to go into this because Right, but no, I will, because it's important. So basically, I'm just using a shortcut since I know that every time I'm just subtracting 7 from each of my numbers. Couldn't I just say that I'm -7, multiplying that out to figure out what my 11th term is? That's my shortcut. You know, and you can use that on your homework this evening here. That's perfectly fine with me. But yeah, don't stress a ton about these. Like I said, we're gonna put these into our calculator. I'll show you how to do that tomorrow, and then there'll be less confusion there. And who wants to write out each of those 11 terms? So yeah. Nemo, are the clouds moving away? All right, good. Sounds good. Yeah, here, I'll grab that. Perfect. Awesome. Thank you. So let's do one more example here before we move on to our last thing, which is geometric. We'll do one more example here. So let's say let's go 10. Let's go. Can I do math? 22. All right. Why don't you guys do that same thing? Why don't you write out what's our common difference? And what is our rule or the formula for this sequence right up there? Second here. Who's got our common difference? What's our common difference here? Who in the back there? Yep. Well, 6 or 6. Yep. And then what's our rule? Go down front there, Mr. T. U of 1 is equal to 4. Okay.
U of n equals U of n minus 1.
Mm-hmm. Perfect. Those are all 3 of our components. Exactly. And just another little hint here. We're always going to start with something like this. Even when our functions start to get crazy or our sequences start to get crazy, you're always going to start with that. It's just a matter of adding different things onto this end. Eventually, where we're going with this is like if we're doing for like population or mortgages or different things like that. This is going to be our end game that we'll be able to do by next week. You know, you could have something like this is what you guys will be doing next week. So maybe even by the end of this week, a little bit. But yeah, but once again, even as complex as this is our home. This is where we're starting. U of n is equal to U of n sub 1. Because it's a recursive function, it's based on the term before it. That's all that means. Okay, our last piece. Well, so this is a real-world example. I don't like it. I don't think it's that great, so we're not going to do it. But this would be a real-world example of that kind of adding seats to and making a recursive function that's based on the previous row. But yeah, so our last piece. So we've been doing arithmetic sequences, and all those have just been plussing or have been adding or subtracting stuff to the previous term. This is going to be multiplying or dividing. So this is a geometric sequence here. So that's what our other term is called. And instead of a common difference, it's going to be a common ratio. And so just like in our previous ones, when our difference, using our familiar one, we're just figuring out what's the difference. What's 4 minus 2 there? That's 2. So that's our common difference. Our common ratio is going to be doing a similar concept here. So let's here. So let's go. This is not an awesome example. So if we use something like that, now it's just a common ratio. So we're doing a similar thing. We're just taking this term, but instead of figuring out what the difference is, we're doing a ratio. 3. So essentially, multiplication and division. That's basically your big difference there. Arithmetic, adding and subtracting, geometric, multiplication and division. That's your kind of simple way to separate for there. So besides that, all the same rules apply. Everything the same applies. So let's take this example here. How do you think you would write our rule for this sequence here? Who wants to give a stab at writing the rule for this sequence here? Let's go right over there. Times by 3. That's it. That's the only difference. It's the only difference between geometric and arithmetic. It's just that we're multiplying, we're dividing. So all these here so this one here is growing, but where you would divide is what if it's going backwards? What if it's 18 sixths and 2? It'd be shrinking. So then of course you could multiply by a third, or you could divide by 3. So that's really the only difference between your geometric and your arithmetic. So common ratio versus common difference, arithmetic, geometric. That's it. So let's take a look at the homework here. Why don't you guys pull out Schoology here, and we're going to take a look. You've got 2 worksheets tonight. How much fun is that? I am going to shorten them down. I try to follow in his footsteps, you know. So yeah. So our first one is going to be this guy here, dealing with just arithmetic sequences. Second one will be the geometric one. Same idea, just adding and subtracting or multiplying and dividing. So this is our arithmetic one. Let's do that. So let's take a look at our first one on here. So I'm going to have you do the evens. We're going to be doing the even numbers here. So knowing that, let's start with an easy one here. Start with number 3, so that's not on our homework. So just finding our first 4 terms. So what would be our first one there? Yes?
Right, is that only even numbers or is that letters?
I believe that there's only numbers on this one. So yeah, it should just be just your evens. But if there are letters, just like normal, even letters and even numbers. So for those of you new, even letters would be like B, D, so on and so forth. From there. So what would be our first term here? What's our first term in this arithmetic sequence here? For this guy right here. Negative 18, I kind of hear mumbled. Perfect. What's our second term? Say it confidently if you know it. I hear negative 13.7. I like that answer because all we're doing here, we're just adding 4.3 onto negative 18. And then, guess what? We're doing the same thing for here and for here. Just going forward. Pretty straightforward there. Let's slide down here. Let's take a look at something a little bit harder. So generating some sequence or some recursive formulas here. So let's do. Let's start number 6. I'll give you a hand here. So, what do we think? What's our first given term for number 6 here? Let's go with Mr. W. Yes, number 6. What's the rule there? And then it is what? Okay. And then what else do we need in this? U of 1 is equal to 10. Yep. Perfect. That's it. Then, of course, finding the 12th term. I'll let you guys do that guy. like I said, just for the first night here, this will be a little bit annoying, but won't be the worst thing in the world. You can always use the trick of multiplying them out, like we did in class here. But I'm not crazy concerned about this. You guys will be able to do that. So, see if there's anything else on here that's worth looking at. I kind of like these word problems, but I'll let you take a run with those there. So, let's take a look at the other guy. Let's take a look at the geometric sequences here. So once again, going to be doing the evens on this guy, and I don't think that there's letters again, but we're going with that there. Let's see here. Let's do one of these. Let's grab let's grab something easy here. Number 3. What is our first term in our formula and all that fun stuff? So we're starting with number 3 here. Just going to do one of these, and then I'll give you some work time. Yes. U of 1 is equal to 0.4. Sure, that sounds great. And then what do you think the rule is there? Mm-hmm. Divided by 10. Yep. And then what's our last piece? I'll let you keep thinking about it. So, remember our rule is? 2. Yep. So yeah, because we're just adding on to there. Like I said, this n thing is the most difficult concept to grasp with this. So don't feel bad if you don't get that yet. You definitely have plenty of time to get that going there. So, and then yeah, in this case here, you could say divided by 10. You could also say multiplied by 0.1, or yes, by 0.1 there, and move on from there. So yeah, that's it. That's our lesson. And that's everything that I've got for you.